Has this ever happened to you? Well, the purpose of this video is to show you how to power out the turnout so that locomotives with short pickup roller distances can pass through Atlas number 5, number 7.5, and double slip switches without stalling using the tortoise switch machine's built-in relays. The problem comes when the pickup roller leaves the center rail here and this gap occurs from here to here. With the short spacing on some locomotives' pickup rollers, that will cause it to short out. So the trick is to use this rail, which is isolated, to have center rail power only on certain occasions when we throw the switch a certain direction. And what will happen is the pickup roller will come off here and hit here, stay powered, and then the gap will be much smaller and it won't stall out. Now, we can't always power this as the center rail because normally it is the outside rail. As you see here, coming from this direction, it'll go across the frog and is the outside rail. But coming from this direction, it doesn't matter because this is just not in use. So when we come from this direction, we can power it as if it is the center rail without shorting out the locomotive or causing any electrical problems. And the way we do that is we use the built-in relays in the tortoise switch machine to power this rail when the switch is thrown in a certain position. And we're going to show you how to do that on this video. What we need to accomplish this is obviously the tortoise switch machine. And I use a barrier strip, and these come in large, they're very easy to find on the internet. And they usually come in a big strip like this, and you can cut them down. There are 8 hookups to a tortoise switch machine, and depending on what kind of switch, what kind of decoders, if you will, that you're using to throw the switch machine, you may use all 8. You may use a total of 9 actually with the Lionel system with where it splits into 2 diodes. But in my situation, I just use 5. And the outside, this will be, we'll call this post 1 and post 8. They go to actually throw the switch machine in a direction. And so in my situation, this one goes to accessory power. This one comes off, splits into a diode, 2 diodes, which are going opposite directions. And then from there, they go right into a Lionel ASC2. And that's how, and then I use the Wi-Fi app, the LCS app, or the Cab 1 to throw the switch. Cab 2, excuse me, to throw the switch. But you could use a double pole, double throw switch. You could use a DCS, AIU, I believe it is, or whatever you want to throw the switch machine. It doesn't really make a difference when we're talking about power routing. Now, the number 2 and number 3 and the number 7 and number 6 are used to bring power in to the switch machine for the relays. And you can use them for anything. Some people use them for signals, and in DCC and HO scale, you'd use it to power the frog. The frog is isolated in DCC turnouts, and so for short wheelbase locomotives, people will use this relay to power the frog depending on which way the switch is thrown. In our situation, we're not going to power the frog. It's already powered. We're going to power that other piece of track that's isolated. So basically, we're going to bring track power directly into number 2 and number 3. And then number 4 and number 5 are the outputs from that power. And those will be routed directly into that piece of track I showed you that we're going to use to simulate the center rail. Now, to make your job much easier, I highly recommend buying this product here. It's called an Aculite. I'm not sure what it's called, but it's made by Aculites, and you can buy them at DCC train shops, and you can buy them in bulk or in single. And what they do is they simply snap in to the bottom of the tortoise switch machine, and then they have screws where you screw the wire in. If you don't use this, you have to solder them on, and because there is some trial and error involved in this process, I recommend buying these, because if you have to solder and resolder and unsolder, many times you could ruin the switch machine. And so that'll come from here. Then I bring this barrier strip in, and I bring the wires out of this into this, and then from here they go on to other places. It just makes wiring more simple. It makes changing the wiring, if you need to, simple, and there's no soldering involved, except for in my case I had to solder diodes because I'm using the Lionel ASC2s. And I will show you what all this looks like later in the video and show you how to do this. Okay, so here you can see the wiring harness. Basically, we've got it all set up here. Basically, I'm using just like 22 gauge wire, and I buy different colors to help me remember what's going on. But anyway, here in position 1, this is a blue wire here, and this is going to go out to accessory power. In 8, you can see the yellow wire. It comes out, and then here I've soldered 2 diodes. The type of diode needed is in the ASC2 directions, and so you just order those online or go to Radio Shack. They carry them, solder them together, and you can see they're going in different directions here. If you look at the diode, there's a silver ring around one end of it, and you need one silver ring going one way and the other silver ring going the other way on the other end of it. So they're going in different directions, and then they split into here. And then I have a yellow wire that comes out and a green wire that comes out and goes to the actual ASC2 itself. And the other side of accessory power goes directly into the ASC2. And then you can see in position 2, I have a black wire that goes straight out. Position 3, I have a red wire that goes straight out, and those will go into black and red track power. Okay? And you can get that track power from anywhere you want. I have a terminal strip underneath which has extra terminals, which I run it straight into here. And then we don't need to run track power all the way to positions 6 and 7. We can just jumper them from positions 2 and 3 to positions 6 and 7. Okay? And it doesn't matter, you could run track power into 7 and 6 and jumper them back over to 2 or 3. It doesn't really matter. And we're also going to have to, like I said, trial and error. We'll get our volt tester out, our voltmeter out, and we'll make sure we've got the power running at the right time to the rail. And if we don't, it's simply a matter of moving these wires, you know, changing the black and red or whatnot to get it the way we want to. And that's why we use these harnesses, so that we don't have to keep soldering and resoldering to get it right. So anyway, what we'll do is we'll go ahead, and I already have the tortoise switch machine installed, so I'm just going to slide that underneath there and then screw this into the bottom of my plywood here, and we'll come back to you in a minute. Okay, here you can see the Aculite is plugged into the bottom of the tortoise switch machine, and there's the barrier strip, and you can see here that in the barrier strip we have blue wire, and that blue wire is going to the negative side of accessory power. I've got it at 12 volts, and that accessory power also powers my ASC2s. The black and red wires go directly to my track power terminal block. And then you can see the diodes go in and they come out yellow and green. And those go into the ASC2, and positive power off the accessory unit goes into the common ports right there, the two white wires. It also, the relays inside of it are powered off that same accessory terminal block. And then you can see the special Lionel wires that hook all of them together. There's a Wi-Fi module, two ASC2s, and there's a block power controller that I'm using. And I'll show you my terminals here. These are the MTH terminals. Now that's track power, so I basically run black and red directly off that to the Tortoise switch machine. And then there's accessory power, which is powered off those Lionel transformers there, which the dial is turned so that it's 12 volts output. And they go directly to power the ASC2s. The blue, which is on the negative side, goes directly to the Tortoise switch machine. And the white goes directly into the common terminals right there. Okay, so it's completely wired up. Now what we have to do is actually tell you what these white wires do. The white wires go into 4 and 5 on the Tortoise switch machine, and they come out, and instead of going into the barrier strip, I have them going actually directly up into that part of the track on the Atlas turnout that we said we wanted to power in certain occasions. So I'm going to go ahead and show you how to do that. What we're going to do is drill a hole through the track with a Dremel, and then we're going to solder the white wires into that hole in the track and run it directly down into our Tortoise switch machine. So we'll go ahead and show you how to do that now. Okay, so now we're going to go ahead and solder in our wires to the rail here. Obviously there's going to be 4 because there's 4 on the double slip machine. If you're doing a 7.5 or a 5 or whatnot, that will just be 2 white wires per turnout. But this one we're going to have 4. And so many people have expressed difficulty soldering on to Atlas track, O-scale track that is. And I have had the same luck. I have not been able to successfully solder on just to the rail and drop it down through. And so I was going through the O-Gauge forum to see what other people have done, and I saw someone who had screwed. He had just drilled a hole and tapped a hole here and, you know, ran the wire up and then just screwed it into the side of the track there. And so that's what the first thing I did, and it worked perfectly. It's marvelous. The only problem is that on, you know, some is that you know, you got a screw head here, and I didn't like that. I'm trying to keep it as 3 rail scale as possible. And then I wish I could remember the member's name to give him credit for this. I certainly didn't come up with this. And that's the greatest thing about the forum, is there's so much, there's a wealth of knowledge there. And if you are the person that put this on the forum, let me know. I tried to find out and I couldn't. But he drilled a hole through the track, a small hole through the track, and then tinned. By tinning, we mean pre-soldered these wires, ran them up through the hole, and then was able to solder them into the interior of that hole. And so I tried that, and it worked marvelously. So now, as you can see, this is a turnout that's already done, a slip switch that's already done. And you can see here where I haven't filed these down. They're still a little bit raised, but you can see here that it's much less obtrusive than a screw would be. And I can file those down even more and make them almost flush with the rail. And so it was a fantastic discovery. And I use it, and it's not too difficult to do. So the first thing we're going to do is we're going to tin the wires as he suggested. And what I use for my flux is I use a flux pen. This is a Kester flux pen number 186. Picked this up off the internet. I really like this. It's not gooey and doesn't get all sticky, and you don't transfer to your trains and stuff like that. And it's really good. So I just go ahead, and it's one of those things where you push down and you just kind of go on each one of these here. Okay, and then the solder that I use is a Kester electrical silver solder. This one is this one does contain lead. It's about 36% lead. So you'd want to, you know, if you're going to do a lot of soldering, you'd certainly want to wear protection, both eye and oral protection of some sort. I'm just going to do a quick solder here. Also, I have one of those blowers that, or suckers that sucks the smoke up, but I don't have it out for this demonstration. So definitely at home you want to use protection. So to tin it, I don't know if you could see this, but it's just a real small. Now, if you can see the difference here, the tinning on this one as opposed to this one, just getting a nice little amount of solder right there. And that's the baby waking up in the background. I don't know if you can hear that, but okay, so those wires are all tinned. And we'll come back and show you how to drill through the track. Okay, so now what we're going to do is we're going to drill through the Atlas rail. I'm using a Dremel with a Dremel 3/64 bit. This is, I believe, 22 gauge wire. Remember, we tinned it earlier. I cut this about 1.25 inches. I'm using 1/2-inch plywood. Basically, I want the non-insulated part to be able to go through the plywood, past the sleepers, and up through the rail. That's why I have 1.25 inches. So we're going to drill with this drill bit through the rail and then down through the board. And then, so we'll be able to see a hole from underneath the board that we got to stick this through. Now, obviously, also, I've been very careful to make sure that I'm not going to hit anything below the board, like the switch machine or an accessory decoder or whatever it may be that you have down there. I've also put a drop of oil on the rail. That way, it helps keep this bit cool and makes it last longer. And it makes the drilling job just a little bit more easy. So we're going to go ahead and do that now. And now I slow it down to go through the wood. And you want to follow the same angle you went through the rail. It's easier to feed the wire up through it that way. Okay. Now the next step is just to clean that rail off, and then we'll feed the wire up through. And I'm just gonna take a paper towel here and get the oil off. And then I'll probably just give it a good sweep with this. And we're back in business. Now I'm gonna feed this up through the bottom here, and you'll it's pretty easy. The trick to it is that you just have to follow the hole's natural angle, and it's pretty easy to feed up through the bottom. So I'll do that right now. it's pretty easy when you just follow the angle, like I said, that you drilled at. And now, what I'm going to do, add a little bit of flux to this here. And I'm going to go ahead and solder this on. Basically just solder down into the hole. And you'll see that this won't glob up. It'll be a nice flowing silver because the wire's pre-tinned, and we're just going to get this solder down into that hole. And there you go. So now you can see a nicely soldered joint on there, and we'll just trim that off. I use these little snippers or whatever you want to call those to trim it off, and then you can do a little filing on it if you want, and it'll blend right in with the rail there. Next step will be to go ahead and wire that wire into either the number 4 or number 5 slot onto the tortoise switch machine. And one thing that is interesting about a double slip switch, which you don't have with the number 5 and a number 7.5, is you have to actually think about which switch machine you're going to wire it into. And you know, a number 5 and number 7.5, they only have one switch machine, but a double slip switch has 2 switch machines. And your logic, you might think that because these 2 joints are soldered here, it would go into the switch machine that's located right here that throws these rails. Well, that's incorrect. And the reason being is because when you throw the route, you're actually using these to throw the route, and you need this tortoise to power route these rails. So we're actually going to take the wires we soldered from this rail, and we're going to hook them into the tortoise switch machine that's on this side of the slip switch. So when we activate this switch machine, it's going to power out one of these 2 rails. All right, so we're going to try to, this is the trial and error part of the process here. We're just making sure that when the turnouts are aligned a certain way, that rail that we have power routed is power routing it the right way. So what we're going to do here is I'm going to start out with the route thrown straight through here. So the train would be coming this way and going down to where those cars are parked down there. So what I'm going to do here is, if I'm a train in this situation, I take my multimeter out, and if I'm a train, basically, you know, obviously the goal is to have this gap, the power gap right here, filled with this rail. So this is a center rail. So when I touch this to an outside rail, I should get 18 volts. And I do. Okay? Now, when I go down to this side, when I touch this rail to an outside rail, I should get 18 volts. And I do. So that tells me that the polarity is correct when the switch machines are thrown straight through in this manner. Okay? So that means that this solder wire here and the one on this side, they go down into the tortoise switch machine, and they receive track power correctly, and the relay is signaling this in the right order. But we have to check every direction to make sure that that is indeed correct. So now what we're going to do is we're going to fire the slip switch to go straight through that way. So that means a train would be coming this way, going through and over to that way. So now what we're going to do is we'll go ahead and take an outside rail, and we're going to touch it to the middle rail to see what we get. Okay, 0 volts. That means the polarity is incorrect for us. I guess polarity, I don't really know, I'm not an electrical engineer. But the rail is wired incorrectly. So to fix that, we're simply going to take whichever, so like let's say that this one, this solder joint, the wire goes to slot number 4 on this switch machine. That means I'm going to change the black and red wires. I'm just going to swap them in the 2 and 3 position. So I'm going to go ahead and do that. But before I do that, I'm also going to check this one, because then I can swap everything at the same time while I'm underneath there. So now, obviously, we think, we're going straight through this way. We want this to be center rail, so we should have 18 volts, and we don't. So what that tells me is that the soldering, the wire soldered to this rail over here, I have to figure out which one tortoise position that goes to and swap the corresponding black and red wires. So I'm going to go down and do both of these, swap them both out, and then we should have the right track polarity when we go through. Okay, so I went underneath the layout and I swapped the black and the red wire out on the Aculite board, which is connected to the tortoise switch machine. And now it should be doing the opposite of what it was doing. And so instead of 0 volts right now, it should show 18 volts. And that's what we want in this scenario. So we'll outside rail touch the cross rail, and we have 18 volts now, as you can see. And so the train is coming this way, and this is the gap. And so we wanted to power this as the center rail in this scenario when the train is routed this way. And indeed, that is how it is now. And so now we've checked going straight through this way, and we've checked going straight through that way. And just to make sure the relays are working correctly in the tortoise switch machine, I'm going to throw it a couple of other directions. Now we'll take it, the train is coming this way, and instead of going straight through, it curves to the right here and goes down this way. So I'll go ahead and throw that. And now, obviously, we should see 18 volts here because the train's coming across here. So we should see 18 volts. So we'll touch an outside rail, touch that, and we do have 18 volts, as you can see there. And now the train curves this way, and this gap needs to be the center rail as well in this scenario, because the train goes this way and we want to protect this gap. We want to power this gap. So we'll touch an outside rail here, and then we'll touch this rail, and we should see 18 volts, which we do. So we know that basically every scenario that the train could move through this slip switch is correct. And I'm 100% confident that now we can run our locomotive through without stalling and without a short. So let's go ahead and try that out. Okay, so let's go ahead and run the train through at a nice slow speed. And as you can see, no more stalling.